Only 64 KB of memory was used to write the software for the world's first ever moon landing Apollo 11 mission. Yes, you heard it right, only 64 KB of the memory. That's even less than the amount of memory we need to save a photo in the current time. Then how did they manage to do something so amazing with so little? Let's understand how the software for Apollo 11 mission was created. Hello everyone, welcome back to my channel. On July 16th, 1969, NASA made a history by landing humans for the first time ever on the moon in the human history. But when they were about to reach the moon, they encountered some errors into the system. There were some errors flashing out into the spacecraft. Everybody on the mission control got so tensed and everybody was on the edge of their seats. But thanks to how reliable software was, there was a prioritization mechanism implemented inside the core of a software which made sure that it prioritizes the most critical task at a time, which allowed the system to ignore everything else and focus on the landing. And because of that, they made a very safe landing. And only 30 seconds later, Neil Armstrong announced it over the radio, and it became one of the most famous words in the history. Eagle has landed. Let's go back to 1961. 8 years before, the NASA made a history. And let's talk about one of the most important people behind this mission, Margaret Hamilton. She was a young computer scientist at that time, and she used to be the director of a software engineering department at MIT. She led a team at MIT of 400 people who were responsible for creating the software behind the Apollo guidance computer. NASA really trusted her to build one of the most important components of the mission, because it was her software which was going to guide the astronauts to land safely on the moon. So everything was planned out by her. Thanks to her dedication and vision that helped NASA to make sure this mission was successfully complete. So before I explain you guys how did they build this software, let me first of all explain you how this software was so crucial for the mission and what were some of the important components this software was responsible for. So the first thing was orbital mechanics. It was extremely important to calculate the spacecraft's position and velocity in real time, because they were about to travel 240,000 miles from Earth to Moon, so it will obviously not going to be just a straight line. They had to account for the gravitational forces of both Earth and Moon, so they had to ensure that the spacecraft stays in the correct trajectory, and AGC was responsible for it. This software was also responsible for the safe landing, because the spacecraft might faced the dangerous and hazardous objects such as big rocks, boulders or craters in their way. The role of the software to detect those and keep the spacecraft away from those dangerous objects. And it was also responsible for the navigation. It was continuously tracking the position of a spacecraft relative to both Earth and the Moon. So now, as we understand for what components the software was responsible for, let's go through how did they actually code the software. So initially they had to write the code using the assembly programming language. At that time there used to be no compilers, keyboards or mouses or anything like that. So they had to write the code into the pieces of paper. They had a huge stack of papers which had the assembly codes in it. Additionally, they had to be extremely cautious and careful about the memory constraints as well, because as I said, they only had 64 KB of memory available. So they had to ensure that while writing each and every line of code, that software is reliable and efficient enough at the same time. Once the assembly code was created into those pieces of paper, the next task was to convert that assembly code into the machine readable code, because how the hell computer is going to know what instructions had been passed to it. So it was very, very important to convert this assembly code into the machine readable code, and that is where punch cards came into the place. Let me first of all tell you what punch cards is. So punch cards are a stiff paper cards with the tiny rectangular holes at each and specific locations. So punch cards has 80 columns and 12 rows, and holes in the each punch card represents one letter. So for example, in assembly code, if I have a letter A, and if letter A represents the hole into the first row of the punch card, that means what programmers are going to do, they will punch the hole into the first row. And when computers are going to read that punch card, it is going to determine that, okay, the hole on the first row represents the letter A, and that is how the entire code was understandable to the computers. And once those punch cards were ready, they had to pass it into the computer through the card reader. And what was the job of card reader? The job of card reader was to scan those punch cards and convert it into the binary. Once the machine code was created, the next task was to how are we going to store all of this memory, because at that time there used to be no hard drives or memory chip like we have it today. And that is where the physical memory called core rope memory came into place. Let me first of all explain you what core rope memory is. So I will tell you to imagine a copper wire, and this is the tiny magnetic core. So this is the copper wire and this is the tiny magnetic core. If the copper wire goes around the tiny magnetic core, that means it represents the numbers 1. Or if the copper wire goes through the magnetic core, that means it represents the number 0. So if the code will have number 0, we will pass the wire through the magnetic core, and if it will have number 1, then we will pass the wire around the magnetic core. So this was the entire procedure of core rope memory. This code was sent to a factory called Raytheon factory. In that factory, there were all the old ladies who used to work, and they were very skillful at weaving. So they were responsible for converting these pieces of paper that had a machine readable code into this core rope memory. This core rope memory was extremely reliable because this was resistant to radiation and physical damage. Both will be very, very crucial for the spacecraft. And this was how NASA built this software using extremely limited resources. That was everything for this video. I hope you have liked this story, and do subscribe to my channel if you want to see more of these videos.